is solved by the so problem of conventional tube is solved by the microwave tubes. So what are the tubes are there? There are two category of tubes. That is O type of tubes. Okay, O type of tubes and M type of tubes. Okay, M type of tube. Okay, already discussed O type of tubes and N type of tubes. Okay, so O type of tube is called linear beam tubes. Okay, this is called linear beam tubes. Okay, this is called cross field tube. Cross field tube. Okay, so now this is the first difference. Second difference is that here electric field and magnetic field, which is H, both are present. Okay, but these are in both are parallel. Electric field and magnetic field, it may be parallel. But here, for the case of your M type tubes, electric fields are also present and magnetic fields also present, but both are perpendicular to each other. So point to be remembered, both are perpendicular to each other. Here both are parallel. Okay, so that's why here now you can say that here the direction of here the for the linear beam tube, for the linear beam tube, the motion of electron, the motion of electron, just now just a minute, just a minute. The motion of electron is in linear one, linear one. Okay, it follows some axis. Okay, but here the motion of electron is not linear, not linear. That means it is a non-linear. That means it is a the motion of electron is nothing but non-linear behavior. Okay, because having the electric field component and magnetic field component and both cross to each other. If electric fields are here, then magnetic fields are here. So it cross both and it form 90-degree angle. So because of the electric field, here only one field come into the both fields are applied into the one directions. So that's why here the motion of electron is in linear one. But here the electric fields and magnetic fields are applied into the both the direction and or two directions and having the 90-degree angle. So therefore, so here the motion of electron is not linear; it is a non-linear. So now, what is example of O type of tube? What is the example of O type of tubes we have studied? Okay, the O type of tubes is nothing but your two cavity. First one is a two cavity Klystron. Okay, two cavity Klystron. Okay, second one is multi cavity Klystron. Okay, and third one is reflex Klystron. Reflex Klystron. Right, reflex Klystron. Right. And fourth one is a TWT, traveling wave tubes, and many more, etc. So these are the examples of your linear beam tubes. Now come to the category of cross field tubes. So I don't have a space, so I am writing here. Okay, what is the example of cross field tubes? Okay, so example is nothing but your magnetron. Magnetron is an Magnetron is the example of your magnetron is an example of your cross field tubes. Okay, magnetron you can take as an example. So sometimes the comparison of linear beam tubes and M-type tubes are asked for 2 marks or 4 marks. So please prepare all this content. for your upcoming exam, or maybe for JNTU exam further. Okay, so now going ahead about the uh, linear beam tubes. Now we can go for the tubes. We will concentrate first on the linear beam tube. So basically, in the linear beam tube, we will concentrate on the klystron. Okay, so klystrons. So here we will see that what is the classification of klystron. Classification of klystron. How you can classify the klystron. So what is a klystron? So you know that klystron is a microwave tube. We have studied. And which kind of tube? It is example of O type of tube. This O type of tube. Okay, this also you studied. Now we can further classify in this klystron tubes. We can further classify these klystron tubes. Now how you can classify it? There are three different classification. Okay, now how you can say? First one is a two cavity klystron. Two cavity klystron. Two cavity klystron. Then multi cavity klystron. Multi cavity klystron. Okay, multi cavity klystron. Then you can say that another one is a your reflex klystron. Reflex klystron. Okay, right. So now, so here, what is the functioning? What is the functioning or working behavior functioning of your klystron? Is it, what is the use of this klystron? Okay, so in terms of application wise, okay, if you talk, there is a two application. One application is amplifier. Okay, another application is nothing but your oscillator. Oscillator. Okay, so here it is an amplification mode. It is in generating mode. It is in generating mode, generating the signal in form of the oscillation. So Klystron can work either as an amplifier or can act as an oscillator. But here, when Klystron act as when you can utilize Klystron in the field as an application of amplifier. Okay, whenever you are selecting the structure of two cavity. Okay, two cavity klystron and multi cavity klystron. This is whenever klystron you are using the two cavity klystron, or you can say that two cavity klystron and multi cavity klystron. Here you can see that these two cavity klystron act as an amplifier to amplify the microwave RF inputs. So it will be amplify the RF inputs and it will produce the RF output. Similarly, if you want to amplify more than use for the two cavity, the number of cavity. Now there is a for the two cavity, the number of cavity that is two. For the multi-cavity, the number of cavity is more than two. But for the reflex klystron, we are not using we are using one cavity. We are using only one cavity. And that is, and the cavity structure is changed. And this time we are using re-entrant cavity. Re-entrant cavity. Okay, here the cavity structures are changed. Okay, so you just remember all these steps. What is two cavity klystron? What is multi cavity klystron? What is reflex klystron? Okay, then we will go further for the discussion about the two cavity klystron. We can further go for the discussion of uh, two cavity klystron. Okay. Till now, is it okay? Is there any doubt? Please ask. Till now, is it any doubt? Please ask me. Till now, is it any doubt? You can ask, please. Anyone? No doubt, I think. So let it be. If anyone found any doubt, he or may she may be asked further. Okay, now I am going to be discuss about the structures of your two cavity klystron, how it look like, and how we can uh, explain about the two cavity klystron. So two things you need to be remember. First one is the block diagram. Means these block diagrams will tell you what is the structures of two cavity klystrons, what are the components of it, okay, and their working functions you have to remember. So here now you can see that this figure represent two cavity klystron. Okay, this is your nothing but two cavity klystron. Okay, so starting from the if it is a two cavity, then where is the cavity? So this is a cavity. This is the cavity number first, and this is cavity number second. But what is there any name of cavity? Yes. So the name of first cavity, that is called buncher cavity. Why it is called buncher cavity? Because electron bunching is happen in this cavity. That's why it is called buncher cavity. Sometimes it is also, if this buncher cavity is located in the input side, that's why it is also called input cavity. Either you can say it's an input cavity, or either you can say it's a buncher cavity. And what the second more cavity, that is named as catcher cavity, because whenever you are applying the electric power supply, then this bunch of electron is shifted to the drift place. Okay, and it is collected to the it is it is it is collected to the catcher cavity. Okay, so you can note it down. You can note it down to the catcher cavities. Okay, so catcher cavities having uh, catcher cavity is also called the output cavities. Okay, so now catcher cavity is called output cavity, and here the bunch of electron is going to be uh, bunch of electron is going to be collect here in this catcher cavity. Okay, that's why it is called catcher. That means sometime like it will collect the bunch of electrons. Now this side you can see that it is negatively connected, and this side because it is connected to the negative polarity of the device, and it is connected to the positive polarity. So here positive and here negative. So from this side, the bunch of electron and the electron which is emitted by the electron gun. And this is actually the electron gun. This bunch of electron which is uh, emitted from the electron gun. It is going to be give the directions using the focusing electrode, and this focusing electrode can focus all electron toward the buncher cavity. Once it reaches to the buncher cavity, in the buncher cavity, uh, we are applying the input. Whatever the input, suppose we want to amplify these input, these RF input. Okay, we want to amplify this RF input having the some frequency, some range like 5 volt minus 5 volt 0. So this is RF input. Suppose this is the RF input. Okay, so this RF input is applied using the coaxial loop, and here it is this field is applied in here. Means so here you can see that there is a electric field because of input, RF input, and bunch of electron. So there is a in buncher cavity there is a interactions between there is a modulations or there is interaction between the electron and RF input. So electron and RF input will be interacted at buncher cavity. So because of this interaction, or nothing but you can say in the buncher cavity there is a velocity modulation. There is a velocity modulation. Velocity of emitted electron is going to be either accelerated or decelerated based on the polarity of your RF inputs. Okay, and then it is formed the bunch, and whenever it is formed the bunch, it is accelerated, and this gap you can act as a B, and this gap you can treat as a B. Okay, so this bunch of electron is going to be drift toward the catcher cavity, and it will collectively catch by the catcher cavity, and whatever RF input you have applied at input, it is somewhat amplified one. And here you will get the amplified RF output because power all the electron in a power is going to be multiplied, and whenever flow of electron from gap A and gap B, there is a flow current density modulation also, and there is a possibility like there is a current is flowing. Okay, and this current can amplify your RF inputs, and here at the output of collector, you will receive the output RF output. So this collected output again it will you can receive with the coaxial loop. You can see that this collector is more positive, more positive. So all the electrons will attract from your electron guns to toward the collector. That's why electron collectors are positive. Okay, so this is the working functions of your electron guns. There are or a two cavity klystron, or you can say two cavity klystron. Now, if you talk about the some concepts about the how we can understand these things using the graph. Using the graph or using the graph, you can understood same working operations. So this is called applicate diagram for the Klystron amplifier. Okay, how you can draw it, how you can draw it, the applicate diagram. These applicate diagrams will tell you how electrons can modulate with the help of RF applied inputs. So now here you can see that suppose let's we will take there are we are not taking bunch of electron which is produced from the electron gun. We are taking only three electron. First electron is a reference electron. Second one is the early electron, and third late electron, that is early electron. So whenever one electron which is reference electron, any electron which is interacted with the this point is called a reference electron. Here there is no field, so reference velocity will be v0. Whenever electrons are emitted early from the electron guns. Okay, all these electron need to be travel same distance for a late electron, reference electron, as well as early electron. This electron has to travel same distance. So timing is fixed, but you need to reach on same place at the same place at this point. This electron is the early electron, means this electron emitted at the time of a starting time or before than all these electron. So what happen if electron is emitted, then means we need to apply the negative field. Once it is interact with the high negative field, the whatever the electron which is traveling with the velocity with the velocity, it is going because of this negative field. This velocity is going to be reduced. and this is this will the value of this velocity, or you can say you can receive minimum velocity for early electron, because it start to travel so early from late electron and reference electron. So here we need to overcome the speed, so that so that the all electron can form the bunch. Okay, so while crossing the bunch, while crossing the from gap A, it is form the bunch. Similarly, your late electron, it is emitted from the electron gun too late from a reference electron as well as early electron. So here we can interact with the positive RF inputs. So if the velocity will be accelerated because of this positive field, and the velocity is going to be increased, so that the velocity for late electron is much greater than the velocity of reference electron. So same things you can. This is for the one cycle. You can get experience. So for one bunch you can form, for another cycle another bunch is there. So bunching process will be there inside the buncher cavity, and all these things you can receive at the catcher end. So now you can see now